All right, next we're going to make use of mass measurements to figure out volume. So this will use just displacement of water. So we start with a cup of water on our balance. So start with the 100s. It's more than 100, more than 200, but less than 300. All right, so it's less than 270. All right, that looks pretty close. So we've got 260, and so it's between the 6 and the 7. So 266 point. I'd say like 7.5. So that's just the water by itself. Then we have this stand that we're going to hang the block from. So we're going to submerge the block. So it's under the surface of the water, but it's not touching the bottom and it's not touching the sides. And so that caused the water level to rise, and so there's going to be a greater mass here, and that difference in mass is going to be equal to the volume of the block, just because the density of water is about 1 gram per cubic centimeter. All right, so we could go back and zero the balance out, but start with the 100s. So it's less than 300. So it's 290 something. All right, so this will be 298, 298.550. All right, and so then the difference between those two masses, again, is the mass of the water, but because the density of the water is 1 gram per cubic centimeter, that's also the volume of the water displaced, and that's the same as the volume of the block. Okay. We're going to just assume that all of those metal blocks have the same volume, so you don't have to do this part multiple times, but you do have to find the individual mass of each of the blocks.